again go for one or two more problem, and then we will just go for next approximation method, that is WKV approximation. So first let's go for next two problem. So again we are taking the same Dirac delta function, but now we will take the Gaussian as my trial wave function. Let's try to see what we will get. So what we have basically, just a minute. So we have our potential. So in the examination, the examiner will give you potential, and that will be, let's say, minus beta delta x. So this is your potential. And we have trial wave function. The trial wave function psi tx is, let's say, this is a e to the power minus alpha x square. So let's say this is my trial wave function, and this is nothing but what? Gaussian wave function. So if this is my trial wave function, obviously the normalized wave function will be, we can normalize it. So this will be 2 alpha upon pi to the power 1 by 4 e to the power minus alpha x square. And you remember, we have already know this value of kinetic energy, average value of kinetic energy on this wave function. So average value of kinetic energy will be h cut square alpha upon 2m. Suppose it will be alpha by 2, then h cut square alpha by 4m. This will be the kinetic energy. So that thing will be given into your test. So always prepare for all these things. But right now I am just going for the very basic level of problem. And now the main target is that we have to calculate what is our potential energy. So average value of potential energy is nothing but integration, and this is between, obviously, minus infinity to plus infinity. And please always remember, if it will give between 0 to infinity, obviously this will be not this value. This will be entirely different value. So always you have to keep in mind. So that will be psi t star potential energy Vx psi t dx. And when this potential is very simple potential, Dirac delta potential. So this is Vx is equal to, you can just take this value, and I think we will get 2 alpha by pi to the power 1 by 2 outside this integration, and we have minus beta is also there, and we have basically e to the power minus 2 alpha x square delta x dx. That will be from minus infinity to plus infinity. And what will be this value? This value is 1. So this value is basically minus beta 2 alpha upon pi 1 by 2. So what is my total energy? The expectation value of total energy we can write here. So average value E is equal to T plus V. So this will be average value of T, average value of V, and this will equal to, we have h cut square alpha upon 2m. And what is potential energy? The potential, the average value of potential energy is minus beta 2 alpha upon pi to the power 1 by 2. So this is your average value of energy. Now what is parameter here? Can anybody tell me is parameter here?
Alpha.
Alpha is parameter. So always keep watch on the wave function. So this is the parameter, okay? And we have to optimize our energy with respect to parameter. This is the main thing. If you will ask me, sir, give me one liner for this particular problem, what is meaning of that? We have to optimize our energy with respect to parameter of wave function. That's it. This is known as basically variational principle. So what we have to do, we will just go for dE upon d alpha is equal to h cut square upon 2m minus all other thing we are keeping as constant, 2 by pi, that will be half. So alpha to the power half, you will just go for differentiation, that will be minus half. Sorry, that will be half, and alpha to the power minus half is equal to 0. So this is all the thing. And always I have told you that keep this thing in watch, that I can replace this particular thing as a function of potential energy, as a parameter used into potential energy, such that my calculation will be very simple. So up to this, I think you are comfortable. So let's go for getting all this value. From here, I can write h cut square alpha upon 2m. Sorry, I have to take this one. Sorry. I have to take this one. So this will be h cut square upon 2m must be equal to beta 2 upon pi to the power half and alpha to the power minus half by 2. So what we have to do, I have to just multiply with alpha on both sides. If I will multiply with alpha on both sides, we will get this value. And this is nothing but the kinetic energy. So kinetic energy is beta 2 by pi to the power half. And here is alpha to the power half by 2. This is all about my kinetic energy. So thus kinetic energy is just half of potential energy. Now, finally, from here we can calculate what is the value of alpha. So you can see that in the potential energy, alpha to the power half is there. So we will, and even in the kinetic energy, what we have done, alpha to the power half is there. So what we have to do, we will just calculate what is the value of alpha to the power half, such that we can avoid unnecessary calculation, isn't it? So this value is, so from here, if I will, so just look at here. So this will be h cut square upon 2m is equal to beta 2 by pi, and this will be half beta by 2 and alpha to the power minus half. So we will just get the value of alpha to the power half from there. Please किसी का ऑन है, आप ऑफ कर लो, म्यूट कर लो अपने आप को, है ना, आवाज आ रही है. So from here we can get alpha to the power minus half is equal to, you can write, so this 2 and this 2 will cancel. So you have h cut square upon beta and pi upon 2 to the power half. So this will be, and alpha to the power half is equal to beta upon h cut square 2 upon pi to the power 1 by 2. And now what will be average value of energy? We will put, this is nothing but the kinetic energy. So we will put the kinetic energy value this one. So you will get the total average value of energy is all about beta by 2, 2 to the power pi to the power half, alpha to the power half by 2 minus, you have beta 2 by pi alpha to the power half. Please mute कर लीजिए. I don't know who is that.
अल्फा टू दी पावर हाफ में सर m कहा गया m.
Where is m? Alpha to the
अल्फा टू
power
दी पावर
half में m
माइनस
ही रहेगा.
m रहेगा.
प्लीज भाई म्यूट कर लो, कौन हो.
सर दृष्टि नाम का कोई है। दृष्टि नाम का कोई है सर।
प्लीज म्यूट योर वीडियो। हु इज दैट?
सर आप भी म्यूट कर सकते हो शायद।
कहाँ से मुझे पता तो चले कहाँ पर मैं पढ़ाऊं या म्यूट करूं।
सर होस्ट से बोलिए, होस्ट से सर।
होस्ट को दिमाग में है ही नहीं, पता नहीं कहाँ है। सो जाते हैं वो लोग लगा करके। दृष्टि, हु इज दैट यार?
चलो इच्छे बेसी में कौन दुध पियानो नहीं पीता हूँ, दूध नहीं पीता ना। जेसीबी करके दो, जेसीबी तो एक चला तो जेसीबी लेकर
सर होस्ट को बोल दीजिए, वो कर देंगे वो म्यूट।
ये पढ़ रहे
वही
हैं कि
बोल रहा
बच्चे
हूँ
खिला
इनको।
रहे हैं?
अब होस्ट को खुद तो देखना चाहिए ना, सो जाते हैं ये। मतलब नहीं है। जस्ट अ मिनट। क्या है यार?
जेसीबी आई तो
क्या नमूनागिरी है? चलो प्लीज आप लोग थोड़ा अपना ध्यान दो भाई, क्या कर रहे हो? आई कैन नॉट अंडरस्टैंड। सारा काम एक साथ थोड़ी हो सकता है। So what we will get? We will get the average value of energy E is equal to, and that will be, I think, minus beta by 2, 2 upon pi, and this will be 2 upon pi to the power half, and alpha to the power half, we will put it from here. So that be beta upon h cut square, and m is also there, m 2 upon pi to the power half. So you can just calculate all this thing. and finally you will get the answer. And what will be this answer? The answer is all about average value of energy, and you can get this value is equal to minus beta m upon 2, and you have 2 upon pi to the power half, and finally you can get 2 h cut square is there. I think this will be your average value of energy. Just you can check it. So is that this will be multiplied now, so this will be gone, this half will gone, and you will get this value of, and 2 and 2 will be also cancel out, so this will be minus beta m upon pi h cut square. Look at how beautiful is this answer, even if in between you have lot of complicated terms, but finally you will get this value of answer. This is very nice, isn't it?
Sir, beta square.
Beta square, yes, yes, beta square, beta is there, beta square. So you can see that they will be in a dimension of beta square m upon h cut square in every time. Only this number is going to change, isn't it? In first question that will be 2, in second question that will be different, and here it is pi. So you can just compare which one is the best trial wave function. Why I am giving you same potential? Because you can just compare that which one is the best trial wave function, and you can just get all these things. Okay, so this type of question will always come into your exam. At least one question will surely come. So if you prepare well, then obviously you can do very well thing. Now you can go for your assignments. So in your assignments you will find a very different type of problems. Lot of calculations are involved into assignment, and that is more than enough. So I will again go for one more problem. So let's go for one more problem for this variational principle. Then we will go for next approximation method, that is WKB approximation. So now we will just go for potential Vx is equal to half m omega square x square. So this is harmonic potential. Let's say this is harmonic potential, and x is between minus infinity to plus infinity. Again, what I am getting? I am getting the trial wave function as same Gaussian, because Gaussian is most important trial wave function. It will fit everywhere. So the a e to the power minus alpha x square, where x is between minus infinity to plus infinity. So this is our trial wave function. So obviously, what is value of a? A will be again h cut square alpha upon 2m, and we will get the kinetic energy. The kinetic
Sir,
energy is,
सर गलत
yes,
होगी सर वो सर
sorry,
एक
sorry,
वैल्यू गलत होगी सर
sorry. A is equal to 2 alpha upon pi to the power 1
1/4
by 4. एक बार जब concentration चला जाता है ना, तो हर चीज गलत होने लगता है. So this will be actually h cut square alpha upon 2m. So let's go for calculating the potential energy. So when we will calculate the potential energy, we have 2 alpha upon pi to the power 1 by 2. I am just writing directly, and this will be minus infinity to plus infinity x square, and you have e to the power minus alpha 2x square dx, and you have to multiply half m omega square. So you have to multiply this thing. So you have to just go for this integration. How you will do this integration? Can anybody suggest me?
सर कन्वर्ट टू
How you
0 टू
will go?
इन्फिनिटी 2 से मल्टीप्लाई
Very good. So you will just go for gamma integral, isn't it? So you
यस
will
सर
just go for gamma integral. And once you will go for gamma integral, the potential energy is equal to 2 alpha upon pi 1 by 2, and you have half m omega square is there, and you will just go for 0 to infinity 2 times 0 to infinity x square e to the power minus 2 alpha x square dx, and this value is equal to 2 alpha upon pi to the power half m omega square by 2, and 2 into this will be 1 by 2, and you have 1 upon 2 alpha to the power 2 plus half, and you have gamma 2 plus half, isn't it? This will be the value. So you can see this is very simple integration. 2 alpha upon pi to the power half. You have this 2 is cancel. M omega squared upon 2, and here 2 alpha to the power 5 by 2, and gamma 5 by 2 is equal to 3 by 2
3/2.
half root pi, isn't it? So
Well,
this
sir.
root pi and this root pi is also cancel, and you have this potential energy V is equal to 2 alpha is here, and this will be 2 alpha to the power 5 by 2 alpha to the power half, and 2 alpha to the power 5 by 2. So what will be this answer? So m omega square is there, and this is 3 by 4. So m omega square upon 8, and this value is
सर
equal to, you can just write, sorry,
सर ये जो होता है ना n प्लस के 1/2 होता है सर
sorry क्या होता है?
सर पूरा कंबाइंड गामा n प्लस 1/2
Yes, sir.
सर
Gamma-
5/2 नहीं आएगा सर
सॉरी 3 by 2 आएगा क्या?
Yes,
Yes,
sir.
sir.
2 sir, yes sir.
Yeah, sorry,
Sir,
minus sign is there. Sorry. This will be minus sign is there. So this will be 3 by 2.
No sir, n
नहीं
plus
सर n प्लस
1
1/2
by 2 होता है sir. Sir, n plus 1 by 2.
Wait.
सर गामा n प्लस 1/2
Wait. क्या होता है? Just a minute. X to the power and e to the power minus alpha x square dx. So this will be value. So 0 to infinity 1 by 2 into 1 upon alpha to the power n plus 1 by 2.
N.
Oh, sorry. This is n plus 1 by 2. Yes.
ओके सर
So this
Sir,
will
the
be
potential is given
Two.
from minus infinity to infinity.
yes.
Sir,
So that will be n plus 1 by 2. This
here we have
there. So
taken
this
from
will
0
be
to infinity.
because I have multiplied with 2, and this is odd. This is even function.
Okay, sir.
This is 3 by 2, and this is gamma 3 by 2. Okay. So this will be m square. And now let us calculate this thing again. So what we have 2 alpha upon pi to the power 1 by 2 m omega square upon 2 into 1 upon 2 alpha to the power 3 by 2, and this will be, what is gamma 3 by 2? Half root
1/2
pi.
यस सर
This will be the value. Okay. So this 2 alpha is half, and 2 alpha 3 by 2. So this will be only 2 alpha is there, isn't it? So here is 2 alpha, root pi is cancel. And we have m omega square upon 4. So this will be 8 will come here. So I think this potential energy value is, this is very interesting. So you have potential energy V is equal to m omega square upon, I think this is 8 alpha, isn't it? M omega square upon 8 alpha. Yes. So this is the value of potential energy. We have value of kinetic energy, and let's go for next level of calculation. By the way, can you guess what should be the answer without calculating?
h cat omega by 2
H cat omega by 2. Why? Because we are taking the exact
harmonic oscillator.
trial wave function. We are taking exact trial wave function. So average value of energy is equal to average value of kinetic energy and average value of potential energy. And this is h cat square alpha upon 2m, and here is m omega square upon 8 alpha. And this will be your average value of energy. Now we will go for dE upon d alpha, and that value is equal to h cut square upon 2m minus m omega square upon 8 alpha square must be equal to 0. And we can write this thing as h cut square upon 2m is equal to m omega square upon 8 alpha square. So I can multiply with alpha. I can multiply with alpha. So this is nothing but what? Kinetic energy. So what is kinetic energy? The kinetic energy T is equal to m omega square upon 8 alpha. So now we will put it here. So kinetic energy E is equal to, you can put, this is nothing but the kinetic energy. So you have m omega square upon 8 alpha plus m omega square upon 8 alpha. We will get m omega square upon 4 alpha. Now we will get the value of alpha or 1 by alpha from here. So you can just use this term and you have the value of alpha here. So what will be alpha here? So alpha, so h cut square upon 2m is equal to m omega square upon 8 alpha square. So this 2 will cancel to 4 and you have alpha square as m omega square by 4 h cut square. And what is value of alpha? Alpha is equal to, so this is m square also. This will be m square, sorry. This will be m square also. So this will be alpha is equal to m omega upon 2 h cut. So you will put the value of m omega upon 2 h cut. I think you will get the answer h cut omega by 2. So this is the trick. You can just get average value of energy is h cut omega by 2. Now this is the story about the ground state. And now sometime if people will ask you and people will give you the trial wave function for the ground state, and what you have to do, you have to find the energy for the first excited state. They maybe give this kind of thing. Suppose they will just give you what will be trial wave function for the first excited state, then you will just follow the same method. There is not problem. But I am asking the entirely different thing. What is the target? The target is first the people will give you the trial wave function for the ground state, and they will ask what will be the energy for the first excited state. How you will approach? This is very interesting. So what you have to do, you on the basis of trial wave function on ground state, you have to go for the trial wave function of first excited state. So how we can go for this? Let's go for this particular, but this is not coming yet in your exam, but I am just giving you intuition. Now suppose, hmm? Hmm. Suppose trial wave function is given something a cos pi x upon a, where x is minus a by 2 to plus a by 2. So this is your trial wave function for the ground state. But what we have to do on the basis of this thing, we have to find that what will be energy for first excited state. So now you can see this is trial wave function of ground state. And what will be this wave function? This wave function is basically for particle in box. You remember? So on the basis of this, the first excited state wave function will be always orthogonal to the ground state. And then we can go for assumption, then we can use the intuition that which one of the following wave function can be orthogonal to this. Then we remember, if I will take the trial wave function for the first excited state, it's something a sine 2 pi x upon a, then x will be between minus a by 2 to a by 2. So if it is the ground state trial wave function, I can use this one as first excited state trial wave function, isn't it? I can use this one as first excited state trial wave function, because if you will take the dot product of this, you will, or you will just take the scalar product, you will get 0. And we also know that if this is your ground state for particle in box, this will be the first excited state in particle in box. So I can use this as a trial wave function for the first excited state. And suppose somebody will give you that trial wave function is something a e to the power minus alpha x square. This is between x is between minus infinity to plus infinity. So what with, so this is for the ground state. What will be for the first excited state? What will be for first excited state? So obviously, this is nothing, it is derived from the harmonic oscillator. You know that harmonic oscillator wave function is something like this for the ground state. The first excited state I can take as a x e to the power minus alpha x square. So this will be my first excited state a trial wave function for any function. So what you can do, you can, on the basis of trial wave function, you can just guess what will be the your first excited state wave function, and then you can use this method and you can get the answer. But don't worry, they will never ask this thing, it is beyond the examination limit. But I am just giving you the extra information that what will be the extra, what will be the first excited state that should be the orthogonal to the ground state. So obviously this is the orthogonal to the ground state. So someone can give you answer, someone can ask you question, suppose this is my trial wave function for the ground state, which one of the following can be trial wave function for the first excited state? So what you will do, you will just check which function is going to orthogonal, which function is going to orthogonal to the ground state. So here, if this is your trial wave function, this is orthogonal. This is your trial wave function, this is orthogonal. Means if one function is odd, then another function will be even in nature, or vice versa is also correct. But they are not going so deep into the this type of theory, but we can solve even if they will ask the deeper question. So thing is that whenever you are going to apply variational principle, how you are doing the integration is the most important thing, and how you are just solving all this problem. Okay, so if you have any doubt, you can just ask me, otherwise I will go for WKB approximation. So let's go for WKB approximation. Okay, so let's go for WKB approximation. So this is a semi-classical theory. Okay, so this is nothing but what? Semi-classical theory. And what is the idea behind this? The idea behind this is the Bohr-Sommerfeld theory. What Bohr-Sommerfeld theory have told, that area under the phase space is quantized. So this is the all idea behind all this thing. So what he say? He say, according to Bohr-Sommerfeld theory. So Bohr-Sommerfeld theory, it is said that area under the phase space for PdX is nothing but NH. And this is only for the bounded system. When system is periodic or it is bounded, then you have closed curve area under the PdX is equal to NH. So this is the particular thing we have done into the early of the of the quantum mechanics. It is a good it is a good hypothesis, but it will not actually give the exact value of each and everything. So what WKB in the WKB approximation, we will just go for this kind of particular integration, and this is nothing but something called about the some p into dx, the calculation of p into dx in a basically phase space, and you can say this will be area under the phase space if it is closed curve. And what he WKV give the different type of quantization of different type of potential. So he just try to change all these things, and on the basis of he just changed this quantization rule on the basis of different type of boundary of potential. So how many different type of boundary you have? He just divided there are three type of boundary: rigid boundary, smooth boundary, means both are rigid, both are smooth, and one rigid and one smooth. And what he give the different type of quantization rule. For example, what is meaning of a smooth boundary? Meaning of a smooth boundary means if x is changing, Vx is changing continuously. So this is the definition of a smooth boundary. What is the meaning of rigid boundary? If x is changing, Vx is not changing. So rigid boundary means it has something like particle in a box kind of situation. But in a smooth boundary, it has something like a harmonic oscillator kind of situation. So what we will do, we will just write this sort of quantization rule for a bound state character. The WK we have also talked about bound state, also talk about unbounded system when you have in classical forbidden region. So when you have bound state system, it is well known that energy in a quantum mechanics is discrete. So what WKV approximation suggests, they will just give you the discreteness value, different type of discreteness value. And once we will use this different type of discreteness value, we can find what will be the energy. So let's go for a different type of boundary first. So there are three cases of boundary. So first is all about both boundary are smooth. So both boundary is smooth means I am talking about something like this harmonic oscillator. So particle is inside this particular trap in this potential, and this boundary is smooth, Vx versus x. Even mod x, this is also a smooth boundary because as x is changing, V is going to change. So these are the smooth boundary. And if this is the smooth boundary, what is the quantization rule? The quantization rule is all about P dx is equal to n plus half h. So you remember this thing. P dx is equal to n plus half h. This is all the condition of a smooth boundary, and n is equal to 0, 1, 2, 3, and so on. Next, this is smooth boundary. Next, what we will go for? We will go for both rigid boundary. So both rigid boundary means this type of situation is there, even it is finite potential or infinite potential, you can have this kind of boundary you have. And what will be the quantization rule here? You have x1 to x2 p dx is equal to n pi h cut. What is x1 and x2? Is the boundary. This is the
Turning point,
turning
sir.
point. X1 and x2 is turning point. So particle is just here. You have to go for the closed curve, but here you have to just go for integration between turning point. So particle is basically bounded inside this particular thing. Suppose this is 0 and a, then we will go for integration 0 to. So there is only one case, that is particle in a box for this case. Okay. And now this is most interesting, and this is your favorite for the examiner. One rigid and one smooth. So this kind of boundary is there. This kind of boundary is there. So if this kind of boundary we have, and this thing is n is equal to basically 1, 2, 3. Sometime this is also given as n plus 1 pi h cut. Then you can take n is equal to 0, 1, 2, 3, and so on. So either you will use this one or you will use this one. Both will give you same answer. If this kind of one rigid and one smooth is there, then what you will go? Again, you will go for x1 to x2. What is x1 and x2? Is the basically your uh, again turning points, and you have p dx is equal to n minus 1 by 4 pi h cut, where n is equal to now 1, 2, 3, and so on. Or you can take n plus 3 by 4 pi h cut, where n is equal to 0, 1, 2, 3, and so on. Both will give you same answer. So what we have to do, and don't worry, in the examiners they will also always give using this condition, find the energy of the given system. They always give you this type of condition. Okay, so
Sir,
this will be n is equal to 0, 1, 2, 3. Yes.
सर डब्ल्यू के भी लिमिट क्या है सर?
W के भी लिमिट क्या है मतलब?
सर एक क्वेश्चन आया हुआ है इस पे डब्ल्यू के भी लिमिट पे सर.
मतलब मैं समझ नहीं रहा हूँ W के भी लिमिट क्या है? How I can give you answer the W के भी लिमिट क्या है?
सर वो
Just give
लास्ट
me
वाला
question.
में
Just give me question, then I will give you answer. Okay? Don't quiz me in between the class. Okay?
सर वो
हाँ
लास्ट
बताओ
वाला
लास्ट
n
वाला में
minus 1 by 4 into
pi
pi
h cut,
plus है ना?
pi h cut, pi h cut.
और लिमिट
It
1 से
is
स्टार्ट है n का.
just I am writing it again. x1 से x2 p dx is equal to n minus 1 by 4 pi h cut. N is equal to 1, 2, 3, and so on. Or either you can use this one or you can use n plus 3 by 4 pi h cut. N is equal to 0, 1, 2, 3. Okay. This kind of thing is there. Now it's clear?
Yes, sir.
Okay. And I don't know what is meaning of WKV limit. So unnecessary, don't throw me jargon. Give me question, then I can solve it. Okay. On which there are n number of limits can be there. N number of limits can be there. On which context you are asking this limit, this is a different issue. So I don't know on which context you are asking this limit. Are you asking this limit for the variation of potential, or you are asking this limit in a something how wave function is going to change, or you are asking this limit what should be the energy of a particle, or you are asking this limit what should be the strength of potential. There can be n number of limits. How I can discuss this thing here? So you can first you will give me question, then I can give you what will be the proper answer. So don't try to mug up the thing. Try to understand the thing. This is simply semi-classical theory. And where is semi-classical theory is going to apply? This is the most important thing. If you will understand this thing, then you can give the each and every answer. Okay. So let's
सर
first go for
वो
हाँ बोलो बोलो.
सर स्मूथ और रिजिड बाउंड्री का कॉन्सेप्ट क्या होता है, थोड़ा बता देंगे क्या?
Smooth means what I am saying. Smooth means this is slowly varying. The potential is slowly varying. What is meaning of slowly varying? The potential is slowly varying means if you are changing x to x plus dx, the potential is also changing with smoothly. For example, x square. If you are changing x to x plus dx, then potential will be changed vx plus dx to the power whole square. Means there is change in potential as we are smoothly changing in the x. But what is meaning of rigid? Means if you are changing the x, the potential is not going to change. For example, here, if I will go here to here, the potential is not going to change. It will remain same, isn't it? And it will change abruptly. It will change very sharply. So when potential is changing very sharply, we will change called it rigid. And mainly rigid means you have something called infinite potential. Okay. So if you just want to ask in a mathematical term, so rigid means infinite potential and smooth means potential as a function of x. Okay.
Okay sir, thank you.
Okay. So let's go for one by one different types of problem and we can solve this thing. Okay. So let's at least we will do one problem. Let's go for this problem. First, it is very simple. Then we can go for next problem in next day because today class was very disturbing. So let's go for this one. Look at, suppose potential Vx is equal to 0, x is between 0 to a and infinity otherwise. And infinity otherwise. What will be the energy according to WKB? So you have to, according to WKB, you have to just give the energy. So what you have to do? You have to just plot this potential. You know this potential is something called rigid potential. So you have identified what is my x1, this is 0. What is my x2? That is a. So we have just identified all this thing. Let's go for the what will be the basically quantization rule according to WKB. So these two are rigid. So both are rigid. Both are rigid. So if both are rigid, we will just go for 0 x1 to x2. We will just go for p dx is equal to n. I will take n plus 1 pi h cut. Then if I will take this one, then n is equal to basically 0, 1, 2, 3. And now how you will write p? This is the most important thing. So you will write P from the Hamiltonian or total energy. So we know we are just using the classical nature. So E is equal to here P square upon 2m. So what is your P? P is equal to root under 2m E. So now we will put it this value into this integration, and this integration will be x1 I have identified 0 and x2 is a. That will be 0 to a, and we have root under 2me dx is equal to n plus 1 pi h cut. And now this value is root under 2me into a is equal to n plus 1 pi h cut. And from here, you can easily calculate the value of E is equal to n plus 1 pi square h cut square upon 2m a square. And what will be value of n? N will be 0, 1, 2, 3. So this is the answer. Simple, straightforward. How you are doing this integration is the most important thing. Once you have done with this integration, you can easily find this answer. And we have also done this kind of integration in classical mechanics. You remember in classical mechanics? Action angle
Yes, sir.
principle?
Yes, sir.
Have you remember?
Yes, sir. Yes, sir.
Yes,
Yes,
sir.
you remember. So that is
Yes, sir.
the quantum mechanical outcome of action angle principle. That's it. In the quantum mechanics, in the classical mechanics, what we have done? P dx is equal to some j. Remember? P dx is equal to
Yes.
some j, and we have told it that is it is nothing but it is action angle variable. And here I am just giving the extra information that if we are talking about the quantum mechanically, then this j is itself quantized. So pdx is equal to quantized, and what is the quantization rule? That will depends on different type of potential. So this is just nothing but extension of action angle principle into the quantum mechanics. So what I suggest, just go to your home and just look at all the problem of action angle. We will do the same problem in the next class. Same problem, everything will be same, and we will just try to get it from the uh, different types of quantum mechanical thing. We have seen vx kx to the power 4. We will just try to figure it out what should be the answer from this particular quantum mechanical theory. So I will just complete this thing tomorrow, and if you have any doubt, you can just ask me. And I request you, please mute yourself. Otherwise, today I lost each and everything. Okay. It is very difficult to deliver the lecture online. Only one board is there. There is constraint to calculation because all these calculations are very lengthy calculations. And if in between, if something is going to disturbing, then it is very difficult for me at least, because I don't have anything written. So everything I am doing the extempore, the same calculation I am doing it as you are doing it also. So I suggest, please maintain your discipline. Okay. So once you are in the class, then you are in the class. That's it. Okay. So please, otherwise it is very difficult. At least in quantum mechanics, it is very difficult because I have to do lot of calculations. Lot of calculation. You will see when we will go for degenerate perturbation, we have to find 9 element from the calculation, and this board is not sufficient actually. One board is not sufficient. At least we need 2 board. Okay. Anyway, so take care. If you have any doubt, you can just ask
Sir,
me.
sir, as the exam is on 19th, till when will we have a class?
Your exam is on 19.
Yes, sir. Hall ticket
Yes,
has
sir.
been
Okay.
all.
Okay. Okay. Then we will finish. We will have class before Diwali, means Friday tak, hai na? Then after Friday